And every time they rolled out of that house in a dehydrated state, they were putting themselves in trouble. See if I can go right directly here. Okay. So, we'll kind of preach to you a little bit. Let's talk about some evidence here. Let me give you some evidence of things, and this is why we know some of the things that we know. You guys have to learn these things by experience. I can't do that. Okay? Like I said, I'm not a firefighter. So one of the first things that we did in the fire service was in 2005, we went over to Maryland, the Maryland Fire and Rescue Institute, and we conducted a physiology study of a training day. And during the course of this training day, they had 3 working evolutions. They had a third floor evolution in a burn tower, and during that they had to hump a 2-inch charged line up 3 flights of stairs, go into a 10 by 10 burn room, set in front of a 2-pallet or 3-pallet fire for 3 minutes and absorb heat, extinguish the fire, and then regress or egress back out. Okay? That was the evolution. They had a first floor evolution where they went in with the same 2-inch, or no, this time it was an 1 3/4 line, charged 1 3/4 line. They went in, there were 4-man teams, 2 guys on the line, 2 guys did a search, pulled a 175-pound mannequin out, and then they extinguished the fire and left the room. That was the first floor. They also had a maze evolution. Some people call it a confidence course, whatever you want to call it. At MIFRE, they get really elaborate. They have a building. You know, they don't have to black people's face pieces out and make things. They got a building that they configure 100 different ways into mazes, and it's 3 stories tall. They got all these trap doors and stuff, and they can configure this thing all these different ways, and they've got diminishing pathways, and they've got places where you have to drop. You know, you have to figure your way around, and so that you're moving feet first and go down, all those things that you guys know about, and I don't, okay? So they had to do these things during the course of the day. These evolutions were in August and September, and it was still pretty warm. We averaged about, ambient conditions were about 85 to 90 degrees and fairly humid throughout the course of these days. Some days it was as high as 95 degrees, other days it was cool as 80. So we were monitoring their cardiovascular function, their respiratory function, and all these kind of things. Well, one of the things we were really interested in was how their hydration status affected their job performance. So when they came in the morning, they reported at 7 o'clock. These were just guys from the Washington, D.C. metro area, D.C., Maryland, right around there. Some guys from Baltimore came down. There were 200 of them all together over the course of about 5 or 6 weeks. And so they come in, they report at 7:30. We tell them, okay, go over to the locker room, get in your shorts and stuff so we can weigh you. While you're there, take a piss, come back. So they go do that. We'd weigh them in, and then we would have them pee in a cup again. And we measured urine-specific gravity as a measurement of their body hydration status. And we'll talk about that measurement later. And then we had them do the study, or do the evolutions. We only measured urine-specific gravity that one time. And the reason why was from the time that they started those evolutions, and they rotated the evolutions in different manners, but from the time they started to the time they finished was almost continuous. They'd have 20 minutes of rest in between, during which time they could drink as much or little fluid as they wanted to. We didn't say anything to them about it. Okay? We just let them do what they wanted to do. Here's one of the things that we saw. Now, from a graph standpoint, I'm a scientist. I speak in graph, okay? And I cut the bottom of this off. Basically, the bottom of this line, this bottom line here, across this way, represents increasing levels of dehydration. So if you're over here, you're pretty well hydrated. And as you progress, you get more and more dehydrated. Now remember, this is a one-time measurement early in the morning. So what we're saying is guys who are over here, these points, were guys who were pretty well hydrated when they came in. And each of these sets of points represents groups of people who were more and more dehydrated when they started the day. Now we know that at some point you lose enough water, your cardiovascular system begins to shut down and you can't work as hard. What we expected was a rise like this, okay, and what we have over here is relative cardiovascular effort. How hard is your heart working? That's what this is. So these guys over here, each of these lines represents a given evolution. Let's just look at one of them here. Let's look at the white one. It's probably the easiest one to see. So in this particular group of people, they were well hydrated when they started, okay? And that first 4 evolution, from a cardiovascular standpoint, was only about a 70% workload. They only worked at about 70% of their maximal ability with respect to how hard their heart was working to complete that evolution, okay? Same evolution. The next group was more dehydrated, and look at the difference. Rather than working at a 70% cardiovascular effort, now they're working at like 82%. Same people, or not same people, same evolution. The only difference is one group was less hydrated than the other. In fact, everybody to the left of this group were what we would consider adequately hydrated. In other words, they were hydrated enough to be out there doing the job. What we expected to see when we looked at this group and this group was that as they were more and more dehydrated when they started, when they did this first 4 evolution, these groups out there would have a much higher cardiovascular effort, but they didn't. It got up here and it basically leveled off. And so the guys are like, what the hell? You know, you're telling us that dehydration causes us to lose performance effectiveness. What's going on? This suggests that it doesn't make any difference how dehydrated we are. Then I had to explain to them that these people right here were so dehydrated and their heart function was so compromised, they were not able to work hard enough to get their heart rate up here. Okay? So those guys on your team or in your crew or in that apparatus with you who are not doing what they need to do in terms of preparing themselves from a hydration standpoint. And their cardiovascular system is compromised. They can't work hard enough to do the job they need to do. What does that mean for you? That means you got to do it for them. This is the interesting thing about firefighters. You know, people like to equate firefighters to athletes. And I understand that. A lot of what you do is very athletic. But there is one very, very important difference. If you're a tennis player or a cross-country runner, a football player, a basketball player, and you don't play very well, your performance is not very good for whatever reason, what happens? You lose the game. You guys don't have that luxury because you guys don't get to set the level of effort is required of you on the job. The fire decides how hard you have to work. You get to the fire and the fire says, okay, here I am, guys. It's going to take this much cardiovascular effort to get me. And if you don't, I'm going to kill somebody, may kill you, and I'm going to tear up a whole lot of property in the process. And those things are exactly what your job is to prevent. Okay, so you go in there. If you've got somebody on the hose line with you who can't cut it, you have to pick up the slack for them. Because just because they can't perform well enough to do what they need to do doesn't mean the fire gets any easier to fight. It stays the same. And you have to work harder, or your colleagues have to work harder to compensate for this. That puts you and all those other people who probably have done things right in jeopardy.